There's been about 350 Nobel Prizes in science awarded, only about 20 of those were to women. STEM is science, technology, engineering and maths-based subjects. So I think one of the problems we have with women in STEM is a lack of role models for children. And this is because women have often been written out of the history of science. So lots of women were involved in major discoveries, but they were never credited for them. So I'm Rachel Tanner, I'm a postdoctoral research scientist here at the Jenner, and I'm also a junior research fellow and a lecturer in human sciences. Women are still really underrepresented in STEM areas, so less than 30% of scientific researchers are women, and in some areas such as engineering it's as low as 9%. And I think this really stems right back to early childhood, where society and culture tends to box children into gender-specific roles. And so, for example, there was one study that found that toys that were based around mechanics and problem-solving and engineering type areas were 3 times more likely to be marketed towards boys. And whereas girls' toys tend to be about more caring roles or appearance-based. And so I think something needs to be done about that. And although in early childhood girls express interest in science, by the age of 15 that's really waned.
I'm Helen Mcshane. I'm a professor of vaccinology at the University of Oxford, and I lead the TB vaccine group at the Jenner Institute.
The Jenner Institute is named after Edward Jenner, who was a doctor in Gloucester in the 1700s, and he was the first person to invent a vaccine, and that was the smallpox vaccine, and consequently smallpox has now been eradicated.
So when I was a junior doctor, I worked in Brighton on the south coast, which has a big gay community, and this was in the early 1990s, so it was really at the beginning of the HIV epidemic in this country. And at that time I had a ward full of patients who were all dying, and they were all dying of AIDS, and it was a fascinating time, and it was an extraordinary mix of palliative care, because all my patients were dying, and very rare opportunistic infections, so rare infections that only people with a very weakened immune system get. So that was what interested me in HIV and in infectious diseases. And people with HIV are more likely to get TB because as their immune system declines, their risk of getting TB goes up. So it was that then interested me in TB and wanting to do TB research. I think mentoring is really important. I often end up with junior doctors and junior scientists, particularly women, coming into my office asking if it's possible to combine a career in science with a career in clinical medicine, and often ask about whether it's possible to have a family as well, and I have 3 children. And of course the answer is it is.
So I've been really lucky that I've had 2 amazing supervisors, both female, so Helen Mcshane, who's my current supervisor, and Helen Fletcher, who co-supervised my PhD. They've both been really incredible role models. So lots of people cite family responsibilities as the reason why women maybe don't succeed as well in science, but they've both shown that you can do both, so you can have it all, an amazing career and an amazing family life. Our group, led by Helen Mcshane, works mainly on TB vaccine development. So when people hear about TB, they usually think it's an ancient or historical disease, but it's actually still very prevalent, and it's estimated that between a quarter and a third of the whole world's population is still infected with TB. And there are about 10 million new infections every year. So it's still a major public health problem. And we do have a vaccine for TB, which is BCG vaccine, but the problem is it's not very effective, and it has very poor protection against pulmonary TB, which is TB of the lung, which is the most common form. And it also has very poor protection in areas that are close to the equator, so the tropics, which are actually the places where TB is most common. So we really desperately need a new TB vaccine. And so our group works on trying to develop new TB vaccines, and we also look a bit at the basic immunology, so trying to understand which parts of the immune response are important in order to better design those vaccines. One of my interests is trying to reduce the use of animals in TB vaccine testing. So at the moment we use animal models like mice and guinea pigs and non-human primates. And the problem is that if you want to test that the vaccine's working, you need to then infect them with TB. which has welfare impacts for the animals. And so the idea is to try and generate an in vitro test, which means in a test tube or in the lab, to replace that so that we can test whether cells can control growth of TB better following the vaccine as a kind of surrogate or a readout of protection. And that would also speed up vaccine development because you could down select the candidates that would go through to further testing.
So it's extraordinary how in my professional lifetime we've gone from HIV being a terminal disease to being an entirely treatable outpatient-based disease. More than 60% of the HIV beds in this country have closed in the last 20 years. And I now say to my patients in my clinic, providing you take this, most of my patients are on one tablet once a day, you have a normal life expectancy. And it's astonishing how that has changed in my professional lifetime.